Now, this video, we're going to switch. We're going to do the same sorts of examples, but we're going to switch. Instead of weak acid buffers, we're going to look at weak base buffers. So the first set we're going to look at is weak base buffers with their conjugate acids in the form of a salt added into that weak base. So we're going to take some weak base. In most of my examples, I'll probably use ammonia. And then we need its ammonium conjugate acid, probably again, this time in the form of a salt, ammonium chloride, ammonium nitrate. Those are good salts to use because those anions don't really, they're spectators. They're very good spectators and don't really do much. So what we're going to look at in this video, again, is the weak base, but then we're going to add the conjugate acid directly in using a salt. So there are, again, two ways to do that. They're going to give you the weak base solution, and you're going to add in that conjugate salt as a form of a solid or a solution. So in this example, we're going to use the weak base solution. So it's going to be a solution. This is 50 milliliters of 0.050 molar ammonia, aqueous ammonia solution. And then we're going to add in ammonium nitrate, the nitrate salt of that conjugate acid, right in there, right, as a solid. So we have the volume of the ammonia solution and the mass of the ammonium nitrate solid. We're adding it directly in. We're not converting anything. We don't have to. We have that conjugate right there as a salt, so we don't have to worry about converting anything. So if we do this, then if we add in this 0.18 grams of ammonium nitrate into this solution to make our buffer, does that really change the concentration of ammonia? Is this enough to change the volume of that 50 milliliters? Probably in the College Board's explanation, they're going to say that this 0.18 grams, that mass of salt added, is negligible. So since we're not changing the volume of this solution, then we can go ahead and plug in that 0.050 molar ammonia, aqueous ammonia, right into the ice table. Now the trick is, what's the ammonium ion concentration? Well, ammonium ion concentration, the ammonium is right there. So we need to figure out how many moles of that we have and the volume. So to figure out moles of ammonium nitrate, or the ammonia first, 0.18 grams of ammonium nitrate. Ammonium nitrate weighs in at 80 grams per mole. So we're going to end up getting 225 moles of ammonium nitrate. How many ammoniums do you get? You get one for each one, so that's also still 0.0225 moles of ammonium ion that you just added in there. Moles is good, but we need molarity. What's the volume? The 50 mils plus the 0.18 grams. The 0.18 grams, the volume of that is negligible, so it's just the 50 mils, so that's 0.0500 liters, leaving us with 0.045 molar ammonium ion. We can plug that right into the conjugate acid place in our table. Right? We have the 0.05 molar ammonia, aqueous ammonia that we plugged in, and now we have the ammonium ion that we can plug in because we just added it into that solution. So again, in this case, what's nice about using the salts is you're just adding that ion that you need directly in. So if we add it in the form of a solid, we got to convert the mass into moles. So we have, right, so we end up with 0.00225 moles of ammonium ion. Moles is not going to go into our ice table. We want molarity. So you take that moles and divide it by the total volume, which is 50 milliliters, 0.0500 liters, which gives us 0.045 molar ammonium ion. 0.050 molar plug goes into our where our weak base is, and our 0.045 molar ammonium ion goes right into the initial value for our conjugate acid. Okay. The second way to add in that conjugate acid salt is by using a solution instead of a solid. Instead of adding solid ammonium nitrate, we're mixing in a solution of ammonium nitrate. So when we're mixing two solutions, we can go ahead and still use that. If we wanted to, we could use the C1V1 equals C2V2, the before mixed and after mix. So for the ammonia concentration, the NH3, that would be the concentration would be 0.50 molar. We don't have to convert this into liters if we don't want to, because it's going to be milliliters on both sides. But I still tend to like doing that for some reason. And then we'll get our new concentration. And, oops, I almost plugged in 75 milliliters there. What is our new volume? So this is the volume before mix. This is the volume after mix. The volume after we mix is actually 125 milliliters. So 0.125 liters. So what's my new concentration for ammonia? Well, if you solve that out, you should get 0.20 molar ammonia. That can go plug into our ice table for the initial value of ammonia. Well, I need ammonium to make a buffer, so fortunately we can do kind of the same thing. So we can take our C1, so that's 0.30 molar. The volume there is 0.0750 liters. That's the pre-mixed values. The post-mix values is going to be the new concentration that I want and the new volume. Notice, again, we mixed it, so the new volume, the mixed volume is 0.125 liters or 125 milliliters. And our new concentration, the mixed concentration for ammonium nitrate is now going to be, what, 0.18 molar ammonium nitrate. We get one ammonium from every ammonium nitrate, so that's our ammonium ion concentration. So mixing two solutions together, right? We're changing the volume of this ammonia solution by adding 75 milliliters of stuff. So we do a quick C1V1 equals C2V2, the pre-mixed value and the after you mixed it to give us 0.20 molar ammonia. This is the initial values before anything does anything, because we're going to add in that ammonium ion directly. So we get the pre-mixed values of the ammonium ion, and then once you mix it, before it does anything, before it sets up an equilibrium, the initial values, 0.18 molar. If you solve out for the new mixed concentration, you can plug those directly into your buffer ice table.